In previous lecture, I already discussed conditional statement. In today's lecture, I will discuss biconditional statement. For conditional statement, symbol is this. For biconditional, both way arrow. Let P and Q be two propositions. The biconditional statement P, then this is the biconditional symbol Q, is the proposition P if and only if Q. The biconditional statement is true when P and Q have the same truth value, else it is false. Means if both true, it will be true. If both false, it will be false. It also called by implication or double implication. Conditional statement called as implication, biconditional statement called as by implication or double implication. How will we express the biconditional statement? We can say P is necessary and sufficient for Q if P then Q, and conversely P if Q. Commonly we use this P if Q. It has exactly same truth value as P implies Q and Q implies P. P implies Q will be false if P true, Q false, and Q implies P will be false if Q true and P false. Here it's false and false, it's false. If from P and Q one is true, one is false, then it is false. If both are true or both are false, then it is true. Let's see one example. Let P equals to you can take the flight and Q equals to you buy a ticket. Then biconditional statement will be you can take the flight if and only if you buy the ticket. Or you can say you can take the flight if you buy the ticket. Now truth table for biconditional statement, when P true, Q true, it will be true. When P false, Q false, it will be true. So for both equal truth value, true true or false false, it is true. When any one is true and other is false, it is false. Till now in proposition, I already discussed negation, then some connectives like conjunction, disjunction, conditional statement, biconditional statement. We can use this connective to build the compound proposition. Let's see how we'll create the truth table for a compound proposition. Here it's given P or negation Q implies P and Q. So there are two propositions. For two propositions there will be 4 rows. 2 for 2 rows. First we'll take P, Q. For P, truth value are true, true, false, false. For Q, true, false, true, false. Now we'll find negation Q. Negation Q truth value will be false, true, false, true. Just opposite of this. Next we will find P or negation Q. For or, when false, false, it will false, rest it is true. Now just check, here it's a false, here it's a false. So here P or negation Q will be false, rest it is true. Next we will find P and Q. For and, true, true will be true, rest it will be false. Now this true, true will be true, rest false. Next we will find this compound proposition P or negation Q implies P and Q. So true implies true, it will be true. True implies false, it will be false. False implies false, true. True implies false, false. So truth value will be true, false, true, false. Like this you can create truth table for any compound proposition. Just partition it and find the truth value for each partition. Then finally combine. Till now in mathematical logic, I already discussed propositions, compound propositions, negation, conjunction, disjunction, conditional statement, biconditional statement. In next lecture, I will discuss logic for bit. If today's lecture is helpful for you, please like, share and subscribe. Thank you.